We're now into discussions of policy. We will come back and have some discussion of biochar as part of the discussion of carbon. And Debbie will come back. But our first speaker is Jan-Erik Peterson. I introduced him yesterday. He leads work on agricultural impacts on the environment and policy for the European Environmental Agency. I have had the pleasure of running into him in a wide variety of contexts. I've asked him to come and both give us his general thoughts on how we make progress on this topic and to inform us a little bit of what's going on in Europe. So, Jan-Erik.
Thank you very much, Tim. Thanks for the invitation. I am actually working on coordinating the next State of Environment report for the European Environment Agency now. Agriculture is sort of part of that, but not really a major focus of my work any longer. And you see that probably coming through a bit in the presentation. I decided details of agriculture policy would not be that interesting. We've heard a lot of things about the connections between different sciences and actions at global and local scale. So what I will try to do is to give my perspective on how we develop an analytical understanding, what we're dealing with, how we can tackle it, and what are important elements of finding solutions. And then there's an annex on EU renewable energy and agriculture policy that I will not try to talk about, but that will be available if you download the presentation from the conference website, including some web links that will take you further. My starting point is what we heard yesterday. We have an environmental system globally that is very stressed. We have a strong increase in global food demand that will increase this environmental pressure. We also expect that biomass demand for energy will expand strongly. There are very ambitious policy targets around the world, not only in the US, not only in Europe, but also in China, in India, in all major economies of the world. No one has looked at what is the combined impact of these targets together. So that's one way to challenge. The other is actually it's not just transport fuels that we need to replace with a more sustainable source. We also need to look at material flows across the economy if we want to decarbonize our society. So do we have enough biomass for all those purposes is a question. No one has the answer at the moment. What I'm going to do is I'm going to look at who can potentially solve the problem for a start. Well, it could be the scientists. We think we have seen they really can make a substantial contribution. Think tanks, they are important. So are politicians. Chinese president, maybe he's certainly very important. Can he solve the problem? I'm not sure. I'm not sure even he can solve the problem. Yeah. But thank you very much, Tim, for bringing us here. I'm really enjoying to be here, and it's a privilege to share the conference platform with so many excellent speakers. I think these guys will be part of the solution. He might be a Portuguese cork farmer. And of course, also the farmers that work in more industrialized systems. These have to be part of the solution, otherwise there is no solution. So that's what my talk will try to tease out a bit. And to continue on that theme, my thesis is policy is about people, not just targets. Because the targets will be achieved if people work towards making them reality. So we have to adjust solutions to the economic, social, and cultural starting point of those who are meant to change, whether it's farmers in different continents, whether it's consumers, or whether it's actually politicians also. And environmental change must be considered a challenge for all of society, not just any particular group. We have heard about the impact of urban consumers' buying patterns on the way agriculture practices develop. If we have a higher share of organic farming and overall purchase, then we will have very likely more environmentally friendly land management. But to be able to understand all this and to handle it, we need to have sufficient management capacity to tailor action well. And I list some elements here. I want to highlight the idea of systems analysis and MDIAK. I'll explain it a bit later. I think that Gary Hirschfeld's presentation yesterday was very interesting in that he talked about some kind of magical tool that they have at the company to look at the carbon emissions from each individual component of their system. It would be interesting to know, what is the resource investment that they make into this system compared to the overall turnover or compared to other direct staff costs. I think that would give us an indication what as society we might have to invest to really get a handle on this, because I believe we don't invest enough as a society. I'll return to that theme. So things have become much more interconnected over the last centuries. Now we have science and technology breaking down borders between continents and markets. I mean, for me, the biofuel issue is a key topic. We have heard a lot about biotechnology. Really what we find is that we can take the same biomass source and convert it to food, to fuel, to fibers, to material we use for furnishing such rooms here, for our clothing. So we have interconnected markets. We also have, through better transport technologies, etc., a much higher exchange between continents, etc. We know that environmental media were always connected. I mean, what happens to the soil will influence groundwater quality, it will influence atmospheric emissions. Human society is becoming more interconnected through the internet, through cheap airlines, etc., etc. But some of these connections, they create problems. Others can be a tool for change. I believe the internet can be a tool for change. It has been already. We have had the very interesting proposal to look at, to improve global land cover data through people working together via the internet, the GeoWiki. I think we can also consider to marry ecological principles and modern biotechnology. That sort of was an option which was mooted during the panel debate yesterday evening. We always have to think, what's the safety margin should we need to leave? Similar to, let's say, the banking crisis, what's the minimum capital that they have to hold in relation to overall lending volume? There has to be a safety net. We have to understand what is the critical threshold there. And we shouldn't push the system to the limits. It was also mentioned yesterday evening. So, everything is connected. How can we see the forest and the trees? Of course, I don't know, but I'm going to suggest some ideas. So the first question is, how do we analyze and prioritize? So here you have, in this slide you have the questions. In the following slide you have some ideas for answers on some issues. Can we identify system critical elements? Banks were identified as system critical. There are also system critical elements in the natural world. What are the biggest wedges? The approaches that deliver biggest carbon savings. What can best be scaled up and where? We have heard that with regard to the biochar question right now. We always have to look for synergies and co-benefits, and for some solutions there may be alternatives that may be even more efficient. So I suggest that rather than looking at individual issues in a monodisciplinary perspective, we need to take a life cycle approach. We have to look towards interdisciplinarity instead of single problem solutions. sometimes we need to solve single problems within a very focused scientific discipline, but ideally they should be placed in an overall strategy. And that has to be, developed through looking at linkages between systems, whether they are the human and the biophysical system, or whether they are systems that are components of our human society. And I would say that healthy soils are critical natural capital. I mean, various speakers have talked about that. If we want to secure our food for the future, want to make soils more climate resistant, use them for carbon storage, they are critical. There are certain critical uses for biomass. And I've listed 3 here, which food is pretty obvious. Fiber and biomaterials is another one. I mean, a lot of the material in this room is created from oil. Oil is going to run out at some point. We cannot, do we have, can we convert energy into material? Not, but we can convert materials to other types of materials, and there is a lot of development in the pharmaceutical industry, in the chemical industries, to use biomass-based sources for actually replacing fossil fuel-derived products. And I think that's critical. Biofuels don't figure here, as you see, but I'll talk about that a little bit later. And at the European Environment Institute, we have done some work, what is the energy pathway that delivers the biggest greenhouse gas savings if we want to use biomass for energy production. And it's actually not the transport fuel chain, it's using energy for heating or for electricity, using biomass for heating and electricity production. It depends on what you replace. And coal is much dirtier than oil is, for example. So if we replace coal that we use for heating, then we have a bigger gain. This is much more complex than I explained here, but we always have to think about how to increase the efficiency of what we do. And I've not listed biofuels as a critical use for biomass because there is not enough resources available and because we have alternatives. If we look at biomass that is sort of produced in natural systems, where they're using only, if I remember correctly, 1/100th of the solar radiation to convert it into actually biomass. So we have a lot bigger and, for a very long time, inexhaustible source of energy that we can use as alternative to biomass as a source. So we should look maybe to solar energy as a principal source of energy, even in transportation systems. On the other hand, if we look for co-benefits, synergies, then we have talked about the opportunities of producing biogas from manure. We can use agriculture bioproducts, corn stover, for example, for second-generation fuels. And that one I have mentioned already. So now, some suggested solutions, some ideas how we can make change happen. And I want to return to the theme, who is meant to act? It's not just African farmers who shouldn't cut down the forest. It's not just politicians who take the important global decisions. It's actually all of us. I think that should be a starting point. And even if a minor step is a step forward. In terms of policy steps, we have to look at how our compartmentalized policy objectives interact with each other. Biofuels has been mentioned as, creating land use that leads to environmental impacts within the regions where they are produced, but also through replacing food production towards other continents. We could talk about that a lot. I'm not going to go in much detail. I believe also we need to consider how can we harness markets rather than environmental regulation. It's nothing new. I'm restating it nevertheless. But not everything should be tradable. There are certain critical pieces of natural capital, I mentioned soils, that we cannot replace. So we need, of course, to have a safety net there. And regulation will play a role. And then I was impressed by the presentation by Tracy Blackmer yesterday. It links to what I say, change is hardest, but most sustainable from within. I mean, we know that from our personal lives. We know it with regard to consumer patterns, but we also know it from research, etc., with regard to how stakeholder groups act. I would hope that research that involves farmers, that leads to direct information flow back to farmers, will lead to a much faster and much more sustainable change of farming practices than any sort of advice that comes from the outside that is pumped into the system by extension services. So we need to consider this, and we need to involve farmers and other actors in developing solutions and thinking about them. And for that we need communication, scientific understanding. And we come to a concept that we talked about 10 years ago at the Environment Agency, which has been forgotten, but which I still think is very important. And sort of, we have tried to look at our business cycle and what we generate and what we want to achieve. And so we are an environment agency that monitors the environment, collects data. Data lead to information that we analyze, that we reproduce, synthesize in reports. And then the idea is that this analysis leads to changes, or if you want to call it improvement in knowledge, by people who act to improve the environment, whether it's decision makers or whether it's the ordinary consumer. So this chain needs to be complete for our work to have an impact. And ideally, if we do our job well, and the knowledge is embedded in the system, let's say in the European Commission, we don't need to exist. So that is then again something to consider. How do we work? How do we organize our work? Do we create a parallel world, or do we interact with the European Commission, for example, in my case with DG Agriculture? I've tried to do that in the latter. I'm not claiming that a lot of, maybe that I have the knowledge, or that knowledge has been really radically altered in the European Commission, but we need to look towards the ultimate goal and not just towards certain output targets. Right, then going back to agriculture policy, because I was mindful that I should speak about that. I have 2 slides on it. I may skip the second one. Who is it for? What is it meant to achieve? Agriculture policy was seen as increasing agricultural production, maintaining agriculture incomes, etc. But we know that agriculture plays a key role in the management of natural resources. So does agriculture policy, therefore. In the European Union's budget, agriculture is listed under the heading Management of Natural Resources. And that's what is one of the official objectives of the EU Common Agricultural Policy, to contribute to a better management of natural resources in the European Union. The actual implementation and the share of different budget lines within the agricultural policy doesn't match this goal completely, if we are polite. But nevertheless, the stated objective is there, and I think we should bear this in mind, that agriculture policy is more than about producing food. But however strong any policy is, and the Common Agricultural Policy has 40% of the European Union's budget, that's 50 billion euros at current rates, 68 billion USD. Nevertheless, I believe even if that was focused completely on improving the environmental management on farms, we would struggle to achieve our environmental objectives because we have strong economic, societal, and technical driving forces that interact with what the policy can do. Young people don't necessarily want to work 365 days a year for very little money. The share of agriculture in national gross domestic product is declining year after year. That means the cake gets smaller. That means farmers have to produce more per labor unit, per 100 euros invested. So they use technology to increase productivity, which has short-term aims, but long-term creates potential long-term problems. Only if we address root forces can agriculture policy facilitate change. If not, it can just slow down change. Sometimes it slows down negative change, sometimes it prevents positive change, depending on the interaction. All right, policy coherence again. Now, in my work, I have actually coordinated the development of EU agri-environment indicators for use by the European Commission and research organizations, etc. And I've argued it's essential that we develop and apply appropriate knowledge. And we have to have an understanding of what we need to change, we need to know how we measure it, and we have to have the people who can actually communicate it in the different spheres where action has to take place. I think I will skip this slide. We can return to it later, Tim, if you think there's interest in it. Yes. So basically, I come to my last slide. And I didn't want to basically focus on hastily drawn up recommendations for changing agriculture policy. But I wanted to return to this item of how do we create resources and capacity to act appropriately. And this slide takes up an observation that I've made over the course of the last 7-8 years. We don't have sufficiently comprehensive and quality control data on trends in the European environment, on structural changes in the farming sector, on management practices in farming. We have a lot of money going into EU research. We have probably 1 or 2 billion euros per year that goes into agriculture research. They're all chasing the same data. They're really doing their very best to develop models on the basis of imperfect inputs. We have a small funnel here that is meant to represent people like my colleagues at the European Environment Agency, or the 2 or 3 people that look at research in DG Agriculture, that are meant then to translate this massive body of knowledge into policy decisions. We have a bottleneck in the third area. If we wanted to develop, or apply resources appropriately across the chain, I think if we had more investment into appropriate data collection, we could develop a better understanding on the basis of fewer research hours, because just the work to look at environmental trends and to connect different data sets would be just much easier. And we would need to increase the capacity in the system, whether it's at environment agencies or directly in policy departments, to sort of translate research results and understanding in their policy decisions. And I think I mention it here because we have scientists and analysts here, people who are interested in influencing policy. So we need to consider how we organize the chain of information flow to finally come to a better informed policy decisions. Thank you for your attention.